Uh, okay. Favor.
Let's humble ourselves and pray. Heavenly Father, we thank you for this day. We thank you for this morning. And we thank you for you have enabled us to wake up, Father. As we are going to have this lesson, welcome your Holy Spirit to come and guide us. And we pray that you enable us understand whatever the teacher is going to teach. May it be a smooth lesson, and we pray that we shall recall whatever he has taught us. We pray that you bless our teacher, bless us all, and we pray for those who have not yet joined, that you give them the grace to wake up, Father. We thank you. In Jesus' name we are prayed and believed. Amen.
Thank you so much, Favor, for the word of prayer. Today we are having our ninth lesson, and in this lesson, our area of concentration is going to be on how to find the length of an arc, and then after that, we shall start looking at some scenarios or some word problems. But here, emphasizing what we call interpretation and analysis plus application. And today we are going to start with what we call the length of an arc. When you have a circle, you can as well be asked or tasked to find out the length of that arc. Take an example. When you look at the buildings, when you look at the different frames. You take an example, some of you have seen those of this nature. Sometimes you may need to know the length from one point to another. What is the length at this point? So in order for us to find that one, it means that we shall need to know how to find the length of an arc. But in order for us to find it, we need to know what is the total distance or what is the length of the full circle. So when I have a circle, this is my circle. Can you respond through the chat? What is the total distance around this circle? What is the total distance around the circle? Or how do you find the total distance around that circle? If someone asks you, what is the total distance for that circle? How do you find it? I'm waiting to look through the chat whether someone knows. When they ask you, what is the total distance of the circle? Thank you, Favor. Yes, yes, yes. Okay, good, yeah. So when they ask for the total distance of a circle, it means you are going to be finding what we call the circumference. So circumference is the total distance you move around a circle. So whenever you move from this, let me say this is my point A, and I move around and I rotate through the whole circle. It means that what I have covered is what we call the total distance. Sometimes even they can call it the perimeter of the circle. So that total distance you move around the circle is what we call the circumference. And now that's where we are going to start from. So we know very well that in order for us to get the circumference of a circle, like the way you have mentioned in the chart, that we always have to get our pi, then times r times 2. So we know that if this is our circle and this is our radius, the circumference of a circle is always given by 2 pi r. Or sometimes you can use your pi d, whereby your d is the same as 2 to r. So this is the total distance. But since here we are only interested in finding just a portion of the distance, it means that if we are to find the portion of the distance, we shall always take into consideration the angle that we have. So if we take into consideration the angle we have, it means that the distance from A to B is going to be given by, so I will say the arc length will be given by the angle I have divided by, you know that the total distance around the whole circle is 360 degrees. Then times the distance I move around the circle, which is 2 pi r. So in order for me to get the arc length AB, I will get the angle divide by 360 times the 2 pi r. So that's how we get the arc length from A to where we have our B. Is that fine, members? That point, okay? Okay, Patricia says yes. Okay, yes. Okay, yeah. So the only difference with the length, you remember when we are in areas, we just say pi r squared. Therefore, when we are in length, we just say 2 pi r because it is the circumference that talks about the distance. So let me ask you to first write. Okay, I repeat. When I want to find the arc length of any circle, I want to find any distance on a circle. It means that the total distance around the circle is given by 2 pi r. But if I just want to find a smaller portion of it, it means that in order for me to find a smaller portion of it, I'm going to look at my sector that is being formed. That this is maybe my A and this is my B. So if the angle here I have is theta, remember here you have your R and this is your R. So if this is our radius, it means that in order for me to get this smaller portion here I'll always look at the angle I have, which is theta, divide by the total number of degrees in the circle, which is 360, then times the 2 pi r. So this is equivalent to what yesterday we were talking about, that when I have a circle like this, like this, like this, like this, you are noticing that this circle has how many portions? 1, 2, 3, 4, and 5. So if someone gives you just one portion, let me say they give you this portion. So it means that this portion is going to be 2 out of the 5 parts of the whole thing. So here, us getting theta out of 360, we are trying to find out how many parts has that circle been divided. So what is the fraction of that part that you are taking out? So that is the 2 out of the 5 of the whole thing, such that you can know how many parts you have taken from the wall. So that's why we say we shall always have the angle out of 360 times the 2 pi r. Hope we are good to go. Are we good to go? Okay. Okay. Yes, Desire. Question.
Sir, good morning.
Good morning.
I've just joined in, so I don't know where.
Oh, yes, Desire, you're going to follow. We have just started. We have started, but the most important thing is for you to know that now we are finding the arc length, and this is the formula that we are going to use. You always get the angle out of the 360. Okay, let me now first ask members to first try out this. Okay. Okay. According to the chart, people are getting 7.82. All right. Okay. Now you are going to allow me to call here. This is my A and this is my B. So we shall say that the arc length of our minor arc of the main arc will be given by the angle divide by 360, then times the 2 pi r. So here our angle, looking at the diagram, is 64. Divide by 360, then times 2 times our pi, which is 22 out of 7, times the radius, which is 7. So we said here the easiest way you can do it, you can first multiply all the numerators at once. So you say 64 times 2 times 22, then times 7, which will give you 19712. Then divide by, then you multiply what you have in your denominator. So you have 2520, and then after you go on and reduce what you have remained with. So here you remain with 7.822, and our units, since this is centimeters, you'll just say these are centimeters. But remember here you are looking at length. So since you are looking at length, it means that you just stop at centimeters. So you don't put the squared. Okay. Part 2 of still the same number. Find for me the distance, or find the length of the major arc. Find the length of the major arc. So those who don't know what the major arc is this side here now. Minor arc is this one here, this small arc. Now we are finding out what about this side that is remaining? How big is it? So that is what you are finding, what you call the major arc. And here, we do not expect you to leave your answer in form of fractions, because fractions are not easy to interpret when it is in terms of distance. Yeah. Yes, to mine.
Good morning, sir.
Yes, good morning.
Sir, I beg your pardon on the major arc and the minor arc. My screen was dark at that time.
Okay, I'm saying that when it comes to a circle, a minor arc is like the smallest portion of yours, is the smallest. When we talk about minor, it is small. Major is something big. So it depends. In case this is my A and this is my B. So this one is, when you look at the overall thing, you are noticing that from A to B is a bit small compared to the part that is remaining. So A to B is what you call the small arc. Then this part that is remaining, this side, this side, this side, this distance is what you call the major arc.
All right. Thank you, sir.
Right. Okay, good. So I've seen answers coming in. Yes, Shakul.
Okay, good morning, sir.
Yes, good morning.
Good morning, sir. I'm
Good
going to
morning.
calculate on the length of the major arc. We are going to follow our formula
Okay.
of the arc, which is theta over 360 times 2 pi r.
Okay.
You will all of me name that the angle on the major arc. We name it x.
Okay.
So to get that x, it's x plus 64 is equal to 360. Then x plus 64 minus 64 is equal to 360 minus 64. Getting x as 296.
196.
Yeah. On our formula, we are going to replace our x, which is the theta now. 296 over 360 times 2 times 22 over 7, then times 7. I think we can first remove the 7.
It's okay. Remove the 7.
Then we are going to multiply 296 296 times 44
Okay.
over 360. Yeah, getting our answer as 36.178 centimeters.
Okay. Thank you. Yes, that is very correct. Joe has a question. He was asking, can't we obtain the circumference and then we subtract? Yes, that is also very fine. So another person would come and say, my circumference is 2 pi r. Then I'll have 2 times the 22 out of 7 times my radius, which is 7. And you end up with your answer as 44 centimeters. Then to obtain the length of what is remaining, then you get your 44 minus the 7.822 because you have already obtained the minor arc. So when you get 44 minus your 7.822, you still get the same answer as 36.178 centimeters. So any approach you use is very fine. So that approach was also okay. However, the only disadvantage it may have over this one is that in case you made an error on the finding the length of your minor arc, then it means that you are going to miss out. You'll miss out almost everything. So as long as if there is any mistake that you made when you are calculating your arc length for the minor arc, and use this approach, it means that you can only get some marks, maybe when you're calculating the circumference. But the person who uses this approach may have a bigger advantage over you. Because if he uses this and he didn't make and he made a mistake on the first one, then he is able to recover. Okay, but all of them are correct as long as you are very careful when you're calculating. Okay, good. So now we are going to start on some activities. I hope this number was enough for arc length. So we are going to start. So let me ask you to first write, or we can start on the activity. So when you look at our activity, they're telling us that we have a chord of a circle subtends an angle of 102 degrees at its center. Find the length of the chord if the radius of the circle is 4.5. Now, for you to be able to do the number, you must know what we call a chord. And we say that a chord is just any line that joins any 2 points along the circumference of a circle. Meaning that if I'll first come up with my sketch, that this is my circle. And now I draw a chord. So here, feel free always. I can decide to draw a chord like that. That one is the chord. And they're telling us that this chord subtends. We say that subtends means something that is going to form an angle when two lines meet. So mean that at the center, and here they told you at the center. So if I have this as my center, it means that I have a line. Let me say this is my line and this is my line. And the angle that is formed by the two lines that are originating from the chord is 102 degrees. And they're telling me that the radius here is 4.5 centimeters. So what do they want us to do? They want us to find what is the length of the chord. Now, the length of the chord, we know that this is our A and B. So in simple terms, they're asking us to find the length from A to where we have our B, knowing that also this one is 4.5. So, are we together on that point? How we have come up with our simple sketch? Okay, okay, we are fine. Okay. Someone who is asking about using pi as it is on the calculator. Yes, that is very fine, please. Okay. Now, after here, there are two, you can approach it in any way you want. There are two ways you can do it. One, I'm going to, when you look at our O, A, and B, those who have done trigonometry 2, you can notice that we have a triangle, whereby here we have 102. Here you have your 4.5. Here you have 4.5 because they told you it is the radius. Now, if this is the triangle we have, and we are interested in finding the distance A and B, let me call this A, let me call this B, and allow me to call this one C. You notice that the distance A to B, and since we have a triangle, we can go back and use one of the rules in trigonometry. So in trigonometry, whenever we want to find that distance, which rule is easy to use if we have one angle and we have two sides? Which rule do we use? Let me sway the people. You can type in the chat. Which rule? Those who did trigonometry 2. Sine rule. Sine rule. Okay. Now, remember, we have very many rules, not so? Yes. There is a rule that will work if you have two angles. Then there is a rule that will work when you have one angle. So looking at our figure here that we have only one angle and we don't have a second angle. So sine rule only works when we have two angles, when we are sure of two angles and we are sure of two sides. But here we are, so I want you to look which rule again, because here we have one angle and we have two sides. Yes, Cynthia. Yes. So here we can apply the cosine rule. The sine rule can work for you given that you have another angle in your figure. So here, when I take you back to our cosine rule, you remember very well that if this is our A, this is B, and this is where we have C. The side where F faces, that is what we call the small a. The side where C faces is what we call C, and the side where B faces, we call it small b. That is how we label them. But when you relate back to this triangle we have 4.5 and we have 4.5. So meaning we have side B and side A. Meaning that what now we want is to find side C. So that means that we shall set our rule starting with C, and we say C squared is equal to A squared plus B squared minus 2AB cos of the angle of the side we are interested in, which is side C. And that is now the rule that we have, that is going to help us here, since we are looking for A and B. So for this case, A and B is the one that we are representing by the side C. Okay, now we are going to fill in our cosine rule. So we shall say our C squared is equal to our A squared plus B squared minus 2AB cos of C. Our C squared is what is represented by our AB squared. Our A squared, when you relate to the diagram, we have the 4.5. So I will say 4.5 squared plus 4.5 squared minus 2 times 4.5 times 4.5 cos of the angle I have, which is 102 degrees. Now, I am going to come, place your calculator now. You say 4.5 squared, what do I get? that I'll have 20.25 plus 20.25 minus. Now I will set 2 times 4.5 times 4.5. Here I'll end up with 40.5 times what is cos of 102. So cos of 102 is negative 0.2079. So we say that whenever you meet a trigonometric function, cos, tan, sine, those ones, always write your answer to 4. More so if at all you are still continuing, even if you write 2 to 5. So here, when we are dealing with it, one of the mistakes that students make, sometimes they subtract 20.25, they subtract these two, yet you cannot. Yes. So the first thing you have to do is to deal with the other part that is remaining. You first deal with this part because this negative is part of, like this one is like one thing. So that is the first thing we are going to deal with. So I'm going to first deal with that one. So I will say negative 40.5 times negative 0.29. So negative 0.2079 times negative 40.5. And I'm getting my answer here as 8.41995, and it is positive. Then that is when I'm going to come and I add on what is remaining. So I'm going to come here and I say now I'll have my 8.41995. Then I add on the 20.25 and the 20.25. So here I'll end up with 40.5. So when I add 40.5 plus 8.4195, I end up with my answer is 48.91995. And this one is what is equaling to my AB squared, or what I'm calling AB squared. So to proceed from here, since there is a square, you'll get a square root on both sides. And therefore, I'll end up with my AB. When you get the square root of what you have, it's going to be 6.9943, and these ones are centimeters. So since here they were writing our radius to one decimal place, then here you can leave your answer as 6.99 centimeters. That one is very, very okay. Members, let me know whether we're on the same page. Have we understood? Okay. Okay. Yeah, that is the okay. Okay. Okay, let's first write, and then I'm going to show you the second approach that we can use for people who are not well conversant with the cosine rule. So when you finish writing, you let me know that we are done. Okay, people have finished. Okay, now the second approach that we can use can be this approach. Now the second approach, you have this is your circle, and we have the distance from here up to here. Here we had our angle was 102, and I think this was what, 4.5, and this was 4.5. Now, you can first divide our circle. I can come here and I bisect. Can the members tell us which angle shall we have here when you bisect? Which angle shall we have there? Let me know through the chat quickly. Which angle are you saying? People are telling me it is 51. Yes. So here we shall have 51. So we shall have 102 divided by 2, which gives us 51. Now, what are you going to do? If this is 4.5, this is 51. Now, I'm going to come back. I remember my trigonometry, so I'm going to draw my triangle. I'll come like this, like this, like this. Here, I'll have my 51. Then I come this side, I have 4.5. So allow me to call this O, to call A, and call C. Now here, the first thing you need to know, you ask yourself, which side are you interested in? That for this particular one, we are interested in finding out this side SC. So I label very well that where my angle faces is always my opposite. Where it sits is my adjacent, and the longest side on my right angle triangle is always my hypotenuse. Then I go back here to my tower. Then I ask myself, which side am I interested in? I'm interested in the opposite. Which side, which length have they given us? That they have given us hypotenuse. So then I ask, what has opposite and hypotenuse? That is my sine. So now I will come and I say sine of an angle will always be given by the opposite out of the hypotenuse. Now, what is my angle? The angle has been given as 51. So I'll say sine of 51 is equal to my opposite. So for this case, our opposite is the distance A to C. So I'll say SC out of the hypotenuse, which is 4.5. Then the next thing, I'm going to cross multiply. So now I'll have 4.5 sine of 51 is equaling to A and C. And please avoid or never write things like this. Some of you, sometimes you make a mistake. When you cross multiply, then you write sine 51, 4.5. So some of you end up multiplying the angles, which is totally wrong. So that one, avoid it. So always first write the digit, then write the thing. So here now, I'm going to say that I'll have 4.5 times sine 51. So whenever you place those trigonometric things, make sure you do it to 4 decimal places. 0.7771 is equal to our SC. So when I multiply 0.7771 times 4.5, I'll end up with my answers 3.49695 centimeters is equal to SC. So now we have got this half here of SC. But since I'm interested in A to B, this distance here and this distance are going to be equal. So now I'll say that my AB will be twice my SC. So now I'll say this is 2 times 3.49695, and I'll end up with my answer as 6.9939, and these are going to be our, I think they were, is it centimeters? Centimeters. So this is the second approach you can use. Members, are we together on that? Okay. Okay, yeah. So you can use any approach of your choice. The one that you feel is a bit much easier for you. Okay, you can take note. Okay, Favor is saying it is better than the first one. Okay. When you finish, you let me know. You said done, and then we continue. Okay. Okay, it seems people have finished. Okay. Okay, now we are going to continue to another number. Let me first ask you to take note of the number. We can first write it down. I have seen gates that look like this. Those who have gates at home, I've seen gates that look like this. I have seen bread that resembles this figure. Even houses, yes, that have such designs. Hope Sheldon, we're on the same page.
Yes, teacher.
Timothy,
Yes, please.
are we on the same page?
Yes.
Okay. Okay, I think people have finished. We are going to start. Now, the first question they have asked us is to find the angle theta to four significant figures. Now, one here, they are testing you because this is geometry and measures. In senior 2, term 1, you learned about significant figures, but also in senior 1, term 1 in physics, you learned about significant figures. So they are testing you for the previous knowledge, whether you know it. So here they are interested in that kind of accuracy and also applying your knowledge that you learned from the other side. Yes, Yin.
Sir, I'm so sorry, but I'm requesting you to help me put back the other questions. Then I just take a screenshot.
Which question?
The one you've just removed. Thank you, sir.
Okay. Now, what are we going to do? The first thing now you need to know is where is my angle? That my angle is here. If this is where my angle is, you ask yourself, this is the angle they are interested in, but what have they given us? So, yes, Mugisa.
Okay, good morning, sir. Yeah, I would like to take you through that number.
Okay.
What you have to do, we are going to first divide 30 into 2. We get 15. That 15 will be the distance from C to where the 5 is 5 meters. That is that angle below 5. Maybe you can put it there like R, where the 5 is, but that side down.
Okay.
Yes. Then if you divide it, you get 15. But I was meaning down. That
Down.
side down.
Where?
Yeah, even there it can work.
Okay.
Then find my angle. I get angle theta. I divide it into 2. I get maybe like x and y. Then after getting that, I use the knowledge of trigonometry 1 to find angle x.
Yeah.
Yes. So from there, I have the opposite and adjacent, whereby the opposite is 15 meters and the adjacent is 5 meters. So I use tan x equals to 15 over 5. Then I cross multiply.
Why?
I cross multiply.
Why?
Okay. I I divide.
Okay.
Then tan x equals to 50 equals to 3. Then tan x, tan inverse, then 3. Then if I press my calculator, but the bad thing here, I don't have a calculator. Maybe if you have, you can press that one in the calculator. Yes. Then after getting the angle x, since I want angle theta, I will get theta equals to x plus y, because all to x. Then theta equals to 71.565. Yes, then you get your angle theta.
Okay. Thank you so much.
Welcome.
Okay. Members, are we on the same page? Let me know whether are, are we on the same page? Yes. Okay. Good. Now, here we have not finished our answer, because since they told us to four significant figures, when you look at my answer, it has 1, 2, 3, 4, 5. So meaning I'm going to reduce and I write it as 143.1 degrees. So that is what I expect you to have. In case you have something different from that, then you need to check out. Yeah, but what is very important, one, is for you to look at your figure. So when you look at this figure of ours, you notice that they had given us something of this nature. So meaning that here you have the distance as theta. Sorry, the angle as theta. Here you have 30, but you don't have any of these sides. But you are in position to know the height here. So the alternative, another person who wants to, I know some of you may want to use cosine rule. So in case you want to use the cosine rule, you are going to come and complete your figure like this. And you say, if I come like this one I know is 15, and this is what? 5. So for you, you first get the hypotenuse. So you use your knowledge of you use your knowledge and you say that hypotenuse is going to be 5 squared plus 15 squared. So when you get your CB here, you'll have your 5 squared plus 15 squared, which is 250. Then when you end up with maybe 15.81. Then here you'll have 15.81. Here you'll have 15.81. Then you can go on and use your knowledge of the cosine rule. You'll still get the same angle. So it doesn't matter which approach you use. From any direction you apply, as long as you have applied well, you'll end up with the same answer. Okay. We continue to the second part. We can have another person take us through the second part. Anyone who wants to take us through the second part? Okay. Now, the second part, they want us to find the angle. Still, we are going to come and ask ourselves, where is that angle found? That angle is the angle here. Now, if that is the angle, you know that when I divide here like this, you are noticing that the distance from here up to here, remember A to B, the whole thing was 30. So if we divide it into 2 equal parts, we shall have 30 out of 2, which will give us 15. Meaning that here I'll have 15. And that 15 is the same distance I have down here. So this one is also 15 meters. And my height here is 5 meters when you look at it very well. So meaning that I can extract my triangle. I extract like that. I extract like that. I extract like that. Now here I'll have my alpha. Here I have my C. I have my B. Then the height here is 5. And here I'll have my 15. Now to find this, you go back to your trigonometry 1, first label your triangle very well. That the side that faces is always my opposite. Where the angle sits is where you have your adjacent. Then go back to your SOHCAHTOA. Ask yourself that what do I have? That in the question, I have the distance for opposite, I have for adjacent. So opposite and adjacent, they go with our tan. So I'll come and I say now, my tan of alpha is equal to opposite out of adjacent. So I'll say now, tan of alpha will equal to my opposite, which is 5 out of 15. So I'll continue and I say tan of alpha is equal to, so you place your calculator, you say 5 divided by 15. What do I get? I'll get 0.3333 and so on. So we say that for trigonometric things, right, in case you are writing decimals, make sure you write to at least 4 decimal place. So here I have 0.333. So in order for me to get alpha, I'll get the tan inverse on both sides. I will say tan inverse of 0.3333. So those who have calculators, you are going to go on and you place now shift tan. So you place shift and tan of 0.3333 and you'll end up with your answer as 18.4332. But the question told us to write to 4 significant figures. So when you look at 18.4332, this is one significant figure, second, third, fourth, fifth, sixth. So you start counting. You want only 4. So you only start, you always, when you are counting significant figures, you start from your left. So this is 1, this is 2, this is 3, and this is 4. Now you terminate from there. Then the next question you ask yourself, whether the number coming after your last significant figure can be rounded up or can be rounded down, or whether it has an effect. So when you look at it, it is a number 3, meaning that that cannot affect this, because the only number that affects this is the number that is 5 and more. So now I'll come here and I conclude that now my alpha is going to be 18.43 degrees. Okay, members, are we on the same page? And are we on the same page?
Yes, teacher.
Okay. Okay. Uh, okay. Good. Uh, Let me call there's someone here. Krilla, kindly unmute. You said kinda. Krilla. Okay. 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 We are going to, yeah. Yes, gift.
Good morning, teacher.
Morning.
Morning. So I'm just asking that how about if you use this right angle from the theta and find the alpha angle?
Yes, that one is also very okay. Yes. You like here, you find the angle here.
No, the alpha, because we already have the x when we
Mm.
divided the x. So how
Okay.
about if you
Okay, you want to
just
say that when you add x plus alpha, you get 90.
yes.
And then our alpha, I don't remember which angle was. It was what? 71.56. Then you say 71.56 plus alpha is equal to 90. Then you say alpha is equal. Yeah, that one is also very okay.
Okay. Thank
Mm.
you.
All right. Okay, you get the same answer. Okay. We go to the next part. But for the next part, you are going to do a part. I also do a part. But now for me, my first part I want you to do for me, when you look at that figure, they want us to find the area of that figure. So in order for you to find it, you are not seeing one, it has a sector in it. So those who are not there, a sector is like that. A sector is this. I will come here, I draw it for you. It's just a portion like this, like this. That is our sector. So meaning we need to find the area of that sector. That is the first thing, number one. Number two, in order for us to find the area, we shall find the area of this and the area of this. And then it means that once we find it, we shall have everything with us. Now, the first thing you are going to do for me is you are going to find for me the area of these triangles, these right angled triangles. What is their area? That is what you are going to first do for me. And then we break the question in two small parts. So everyone, remember down here, we have 15. Here we have 5. Can everyone first find out what do we have for the triangle here? I'm going to call this triangle here our A1. I'm going to call this triangle here our A2. Yes. So find for us A1 and A2, and then after put for us in the chat what answers you have for those areas, A1 and A2. Okay. I think people have finished. People have finished. Okay, 37.5 for both, 37.5. Okay, good. Okay, 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 okay. Okay, okay. Uh, uh, Sheldon,
Yes, please, teacher.
yes, take us through how you have obtained your answer.
Mm, I extracted one triangle.
Mhm.
Then I used the formula, a half.
Okay, area is equal to a half.
Base times height.
Okay,
Then a half times 15 times 5. Then I first multiplied. I got 75 divided by 2. Then I got the answer as 37.5 centimeters squared.
centimeters squared. Where are you getting the centimeters? Look at the units again.
Oh, sorry, meters. Yeah.
Meters squared. Okay, thank you. Yes. So when you look at the two, they have the same. So your A1 and A2. Now, after that, we are going to extract our sector. So we have this, and we have this. So in our number one, we were able to obtain this angle, and I think we got this angle as 143.1. Now, the only thing we don't have, we don't know the radius here, the radius of this. So you come back here, you can notice that your radius is the same as CB. So can everyone first find that radius? Remember, this is your right angled triangle. Not so? Here you have 5, here you have 15. So can we find out what is the radius for that circle using your knowledge of Pythagoras theorem? Mm. Okay, Chinese word, yeah. Eva, okay. Yes, desire.
We have got 15.81.
Okay. 15.81. I'm seeing Daniela, Magezi, they're getting still 15.81. Very good. 15.81. So let me hope everyone is getting that 15. So we are going to come here and we shall put here 15.81. Also here, we shall have 15.81. So yesterday, we looked at how we find the area of the sector, and we said that to get the area of the sector, we shall always get the angle, divide by 360, then times the pi r squared. So can everyone now first find out what we have for our area? It's Calvin, Chemtai, and Caroline. Hope we're on the same page.
Yes, sir.
Yes.
Yes, teacher.
Yes, sir, we are.
Okay. Elijah, Emmanuel, and Ethora. Hope we are also on the same page.
Yes, sir.
Okay. What about Hannah Msime, Hanake?
Yeah, literally just joined today, woke up late, so we are not on the same page.
Oh, sorry. But Hannah Msime, now we can pick up from here, like yesterday, you were around. So first find the area for the sector is what now we are breaking. Okay. Okay, Hunter is getting 312. 0.266. Again, Jonah is also getting that. Okay, good. So the rest, hope we are getting those answers. So here we shall have our angles 143.1 divided by 360 times our pi, which is 22 out of 7, times our r, which is 15.81 squared. So when you place it in your calculator, place it very well. Place it very well. So when I place, I'm getting something like this. Please also place yours and see what we are getting. Then those who don't know, we got 15.81. Please, we use the Pythagoras theorem. Hope everyone has obtained. Okay, I think with my 26, I think I'm saying 266. Okay, let me just see. 143.1 times 22 times 15.81 times 15.81. Okay. When I multiply what I have in the numerator, I end up with something like this. Then when I divide it by 360 times 7, 360 times 7, oh, I end up with 302.266. Okay, 6 something like that. And these are meters squared. So in order for us, since they told us the area of the wall, it means now we are going to add all our areas. This one here is what I'm calling area F3. So we shall add the area of the wall, which is going to be A1 plus what we called our A2 plus what we called our A3. So we have 37.5 plus 37.5 plus now your 312.266 or 6. So when you add, you end up with so you can add and see what you get. Uh, 387.2666, and I will say meters squared. Okay, are we on the same page, members? Okay, we're on the same page. Okay, yes, you let me know whether we can now continue. Okay, are we good to continue to another number? Oh, where did the 143.1 come from? Okay. Magezi?
Yes, sir.
Yes. What is confusing you?
Where the 143.1 came from.
Okay. Magezi, do you remember this part?
Yes, sir.
Are you saying the 143?
Yes. Yes, I am. Yes, sir.
Okay. You have seen now?
Thank you, sir.
Okay. Okay. We'll go to another one is here. first, right? Stefan is asking where the 15.81 come from. Yes, remember, we, as the rest for you can be writing, we had our figure of this nature, like this. Here we had 15, and here we had like 5, the triangle. Or here there was 5, and here was 15. But remember, for this particular sector that we want, remember the sector, we use the radius, so we must have this radius here. But we only have the adjacent and then the height. So to find this one, it means that you must be able to find this one, the radius of the circle. So to find it, you can note that you are forming a right angled triangle, whereby this is 15 and this is 5. So meaning that this side is what we don't have, what we call C. So C squared will equal to 15 squared plus 5 squared. So when you place your calculator, 15 squared, you get 225. Then plus your 25, which will give us, this is about 250 is equal to C squared. So you get the square root, get the square root. So your C will equal to the square root of 250, which will give you 15.81. So meaning that here you have 15.81, here you have 15.81. So now that is how we can be in position to get the area of this sector. But it came from there because we didn't have the radius for the circle. Okay, when you finish, you let me know. And then okay. Okay. Yeah. Now they are telling us that we have this particular farmer who is doing sheep, is keeping sheep at home, and they want us to find the area that the animal grazes in. Now, the first thing we need to know, some of these numbers you may need even to have some assumptions or to assume something. So when you look at the sheep, you know very well that when they are moving, there is some kind of path. We shall, when you go into term 2 of senior 4, you'll study about what we call a locus. So they form what you call a locus. Whenever you tie something on a fixed point, its movement always traces a circular path. And that is what we call a locus. A locus is a path that is being traced out by an object. So this shape here is going to stretch, you know very well, those who have animals at home, they will always stretch themselves up to when they finish that thing. So at the end of the day, you are going to see it coming like this, coming, eating like this, like that, like that. Okay, my thing has not come out well, but it will make a figure of that nature. And if you try to complete, if at all this fence was not there, it would have completed the figure up to like that. So it will form that circular kind of path when it is moving. But remember, they have told us that it is being restricted. It is being restricted because there is a fence somewhere. I don't know whether we're on the same page. Kindly let me know whether you have understood up to that point. Are we there? Yes. So what are we going to come up with? You are going to notice that this is where I have my fence. And that shape is going to move in this format to rotate. So it will eat. So, but allow me to draw some backward thing. Now, if I label this as my fence, because they told us it's a straight fence, A and B, looking at the knowledge so far we have looked at, what is the special name for A and B? What is that special name for A and B? That distance A and B. From your circle theorem thing, how do you call A and B? Good. Yes. So A and B is what now we call our chord. So the fence for this scenario, it is standing in for the chord. Remember, this is where the my circle, okay, my art is not so good, but you'll understand. So they have told us that the distance from where the ship is up to where the fence is, they have given it to you as, I think they gave it us as 6 meters. So here you have 6 meters. May I ask you, people, to tell me, what about, allow me to call this my center O. What is the distance from the center O to B? Through the chat, what is your OB? OB, OB. Hey. OB is the radius. And Hika has said is the radius. Very good. So our O to B is going to be our radius. And our radius is equal to what we call our rope, where the thing. And it is even, people have said it is even 9 meters. Very good. So here we are going to have 9 meters. Similarly, the same thing is going to happen. Also here, we shall have our 9 meters. So the area where this sheep is going to graze from, where the grass is, this is the area where the grass is. Around here, where this is where I'm putting the grass. This is where the grass is. Here, 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 here. There is grass here. So the area I'm putting the grass, that is the area. They want us to find that grazing area. Much as this side, there might be some things, but there is a fence, so it can't reach here. So this area is what they want us to find. So, but here, remember, you're going to do it yourself. For me, I was just helping you to come up with it, to visualize it, and then we start. Now, the first thing we are going to do is that here, we need to find out, what do we have? We don't have any angle, but when you look at it very well, you have, this is our triangle. When you look at it, you have a triangle. This is A and this is B. On that triangle, you have something like this. And this is where you have our 6 meters. This is 9 meters and this is 9 meters. So I'm very sure each one of you can be able to find the area of the triangle. But now, what about this other area, the behind area, where we have? But when you use your knowledge, you can notice that we can be able to find the angle, because this area from A to B, we can find that area because it is representing our major sector. So may I first ask everyone to find for us the angle we have here. That is your first task. Let us first find out which angle do we have at that point. Good enough, you have your 6, you have your 9. So label it very well that this side is where I have my opposite. This one is my adjacent, and this one is my hypotenuse. So can we find out the angle we have at that point? Use your knowledge of trigonometry. Okay, someone is getting 48. That is Hunter. Okay. Someone can raise up the hand and you take us through how you are getting that angle. 48.2, that is Jonah. Anyone? Okay. Yes, Jonah.
Good morning, teacher.
Yes, good morning.
To find the angle there,
Mhm.
we are given adjacent and hypotenuse. So we are good to use cos.
Cos, okay.
So cos theta is equal to adjacent over hypotenuse.
Yes, sorry about that. I had forgotten to plug the router in power and it ran short of it. Okay, so but I'm back. So here, by the time I left, Jonah was telling us that the adjacent is 6 out of the hypotenuse, which is 9. So I will expect that now we have 6 divided by 9, and you get your cos theta as 0.666 and then 7. So when you continue, you'll find that your theta is equal to cos inverse of 0.6667. So when you place shift, then the cosine of 0.6667, you end up with your answer for theta as 48.187 degrees. Hope we reached that point. Now, but when you look at the whole thing, we have only found out this particular one, which is 48.187. But also we need this. So you remember also, since it is the same thing, also here, you'll have 48.187 because this one and this one are equal. So meaning that these two angles are also going to be the same. So that means that the total angle we have around this point, around this region, is going to be 48.187 plus 48.187. And when you add those two, 48.187 plus, okay, all times 2, you end up with your answer as 96.374, which I can write to one decimal place as 96.4 degrees. Members, let me know whether we're on the same page. Are we on the same page? Okay. We Okay, Aini is saying no. Aine, can you let me know where the problem is? Aini?
I'm getting 0.84
For which part?
for the theta.
Theta? How are you getting 0.84?
Using cos inverse.
Cos inverse. Have you placed in 0.667?
Yes.
And you're getting what? 0.84. Oh, now you first reset your calc. Your calc is in another mode. So it is in radians. So you go to shift, you press shift, then go to mode. You press shift, mode, then press number 3, which is for clearing all, then press equals, and then press on. Finished?
Yes.
Now you press shift cos inverse of 0.6667. What do you get?
Okay.
And please, whenever you are doing the trigonometry, make sure that your calc is not in radians. Otherwise, you may get all your answers very yes. Okay. Now we are going to continue. Oh, sorry. I think I'm going to use the same space. Now, when you look at what we have, you are noticing that this angle here is our 96.4. So those who remember very well, when you look at what we want, I can find what I have this side, the angle I have this side, because now we have a figure of this nature, like this. And when you look at this side here is what we call our major sector. So my question is, do members know how to find the area of the major sector? I'm very sure those who have been on know it. So in order for you to get the angle here for the major sector, we shall say 360 minus 96.4, which will give us 263.6. So meaning that here we are going to have our angle as 263.6 to find this grazing area for the major sector. So I'm going to come here and I say now area of the major sector. So like we said, in order for us to find it, always we get our theta out of the 360, then times the pi r squared. Since our angle is already known, it is 263.6 out of the 360 times our pi, which is 22 out of 7, times our r. Our r is 9, because remember here you have 9 and this is 9. So here I'll have 9 squared. So can we place in our calculators and you let me know what do we get for the angle? Yes. 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 For degrees, yeah. For angles, yes, 1 dp. And you let me know what do you have for the area for that major sector. Okay, I'm saying 186.4, 186.4, 186.4. Good. So here we shall write as our 186.40. Some are getting 3. Okay, around there, 8.604. And these are, I think it was meters squared. Okay, now after getting the area, it means that we have obtained this area here for the major sector. But also, remember, we have the area here inside, here. So we need also to find out what about this grazing area here. And when you look at it, this is a triangle. So can everyone at least first find out for the area of that triangle? Find the area of triangle A or B. Find the area of the triangle A or B. Triangle A or B. So I expect you to have something like this, whereby this is 9, this is 9, and this is 6. So find out. Here you have your A, here you have your B, and you have your O here. So there, feel free. Yesterday we looked at how we can get it. Yes, you have here very many ways you can do it. Yeah, it is up to you which approach you want to use. But yesterday we looked at 2 of them. So let me say here the first approach someone can use, and we have another approach number 2. So it is up to you to use which approach you want. Okay, people are getting 40.24, 40.24. Okay, 40.24. Good. Now, those who were not with us yesterday, we said to obtain the first approach that maybe I can use. We say that to get the area, remember here, we already have our angle, and our angle was 96.4. So I can say always I get my angle. You can use the half. This is r squared sine of theta. And I say this is a half times our r, which is 9 times 9 sine of 96.4. So the moment you use it, you'll be able to get your 40.2, I think 24. That's what I've seen the members, right? 40.24. Then when the second approach is you breaking your triangles. When you look at them, you have a triangle of this nature. So for you can decide first break down and say, this is 6 and this is 9. But here, meaning you need to find the base of the angle. Here, use your Pythagoras theorem. You say 9 squared minus 6 squared, then the square root, which is 6.7. So here you first find that here there is 6.7. And then you go and say area is a half times the base, which is 6.7 times 6. And then you get that first area, which is 6.7 times 6, divided by 2, which is 20.1. But since there are two triangles, this triangle and this triangle, you multiply by 2. So you'll get your 40.2. So that is the second approach you can use. Then now we are going to find the total area. So the total area for all the grazing area, it means that we are going to add the area we have here, which was 186.40 plus our area we have obtained, which is 40.204. And we shall end up with 6. So we shall end up with 226.64. And this, since it is area and we have meters, we shall say meters squared. Then you can conclude that the total grazing area for the sheep is 226.64 meters squared. Members, are we on the same page? Okay, first thing here. Okay. Yes. So in case you have a question, you can raise it. Yes.
Sir, may I know what we were calculating by the time we got that answer of 40.24?
Oh, what we are calculating, when you look at our grazing area, it is the whole of this, not so?
Yes.
Yeah, but here we first found out this part here. Did you get that part?
Which part?
This one here I'm shading, for where the sector is.
Yes.
Yes, but now, still to get the total area, remember there is also this part here where the triangle is here.
Yes.
So this is the one that we are finding out.
Okay.
When I take you back here to the grazing area, you can easily see it that when it comes to this grazing area, you are forming a figure for the what? For the triangle. So you have this, you have this. So you have to find the total area for this triangle here, and then also this side where you have your major sector.
Okay, sir.
Okay.
Thank you.
Okay. Have another one we can write. Okay, as I answer, yes, stressing.
Teacher, where did 263.6 come from?
Where?
Did 263.6 come from? 63.6.
This one, eh?
Yeah.
Now, remember, we had, did you get how we got 96.4?
Yeah.
Yes.
I
So
got
you know
it.
that, yes, angles on a point add up to 360 because this is a complete circle. So to get how many degrees are remaining this side, the behind part, we get 360 minus 96.4.
Oh.
So that is what gave us
Okay.
263.
Thank you.
Okay. All right. Okay. So let's write that question. Okay. Yes. Okay. We got 6 points. Okay. Okay. So, and we add, according to our circle was like this. We had a triangle of this nature, whereby here I had 9 and here I had 6. So we wanted to find out the base for this triangle. So when you look at this triangle, this is the longest side. So when I'm using Pythagoras, this is C, this one can be your A, and this one can be your B. Remember, this is where the right angle. So you say A squared plus B squared is equal to C squared. So your A squared is what we don't have, plus B squared, which is 6 squared, plus C squared, which is 9 squared. So this will give us A squared plus 36 is equal to 9 squared, which is equal to 81. So we take the 36, we get A squared will equal to 81 minus 36. So our A squared will equal to 81 minus 36, which will give us a 45. Then you get a root, take a root. So when you take a root of 45, you end up with A is equal to 6.708. So that's where we got it. Hope and we're okay. And are we together? Okay. When you finished, okay. When you finish, you let me know. Okay. Someone saying we continue. Okay. Okay. They are telling us that a square field with a side length of 8 meters has a goat tied to a post located at the center of the field. The goat is tethered to the post using a rope of length that allowing it to move within a specific range. The rope length restricts the goat's grazing area to within. Your task is to determine the area of the square field that the goat can actually reach, considering the boundaries of the field. Now here, you need to know, like to visualize it and say, how will this goat move? Now, one thing, like I've told you, whenever you tie something, let me say this is uh, this is this is the pole. When you tie something using a rope, this thing will always trace out something circular, a circular path of that nature, always. If you want to look at it very well, those who have animals at home, you can check out that the area where they stay, those who are tying them on ropes, you'll find out that they have made that circular path around what we call the locus. Still, when you look at this goat, when it will be moving, it's going to trace out that circular path. And you know that whenever you trace out a circular path, the distance from the center to any point along the circle is going to be your radius and will be the same. So this goat, when it is moving, it will reach somewhere and it will trace out something like this. Something like that. I don't know whether members, that is very fine. Is that first step fine? What we are tracing out? Okay, it is very fine. Now, after tracing that out, you are going to notice that the area, there are some areas that the goat is not going to be able to reach. So those areas where the goat is not going to be able to reach, take an example here in the corner of the square field. It will not be able. Here, it cannot. Here, it cannot. Here, it cannot. But when you ask yourself, you need to also remember that this goat is going to go even beyond the boundary. So what are you noticing? You're going to notice that beyond the boundaries, we are going to form, we must eliminate them. Because here, to find the area, it means that we are going to find the area of the whole thing minus the boundaries. But remember, it is not going to be able to go here, 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 here. So we need to remove them. So when I draw here, I can have a line. I join here like that. What does it mean? It means that I have formed a figure of this nature, a figure which we are calling the sector. But along the sector, there is the minor sector. We don't, that small part, we don't need it. What we call the small segment or the minor segment, we don't need it, meaning that we must remove it when we are doing our calculations. Now, members, let me know through the chat. What do you think, before we start removing it, what area are you going to first calculate first? Which area do we need to calculate first? Yes, Desire?
Of the triangle.
For the triangle? Okay, that is one. People are saying area of the sector, square, area of the sector, sector. Okay. Okay. That is okay. That is okay. So we are going to start on our approach. Now, so I've made it a bit more. You can now visualize it in another format. Yes, so that is it. Now, may I ask each one of you to first find out what is when you look at that figure, remember, we are going to eliminate. We are going to eliminate these areas here. We must remove them because the goat doesn't reach there. So what does it mean? It means that we must know what is the area of the whole circle. That is the first thing. After getting to know the area of the circle, what about the area of the sector? Is that fine? Now, can we first find the area of the whole circle? Everyone, that is the first thing. What is the area of the whole circle? Hannah Museme, are you picking something?
Yeah, I'm not really done.
We are finding now the area of the whole circle.
I've got 63.64.
I beg your pardon?
I have got 63.64.
63.6. Take us through how you have reached there.
Okay, so area equals pi r squared.
Area is equal to pi r squared.
Yes, then I need pi 22 out of 7
22 out of 7.
times 4.5 squared.
Okay.
Yeah. So when I squared 4.5, I get 20.25. So it was 22 out of 7 times
Mm.
20.25.
Okay, so your final answer is 60.
63.64.
64. Okay. And these are meters squared. Okay, good. Okay, now that is the first one that we have found. Now the next one we are going to find is the area of the sector. Now we have our sector. We have our sector like that. Here you have your 4.5. You have your 4.5. But we cannot find the area of this sector minus us knowing the what? The angle. So that is the first thing we have to find, the angle. But when you look at this number, you cannot use the cosine rule, you cannot use the sine rule because you don't have all the angles. So what are you going to do? You're going to come to your figure and notice very well that I can find this height here. Members, through the chart, what is this height here? That is the only thing that is going to save us to move forward. What is the height? Okay, okay, okay. 4.5, the height. Well, what is that height? 4.5. Why 4.5? Why are members saying 4.5? Others are saying 4. So someone to defend their answer. I saw Magez. I saw Daniela. Okay. I want someone you must be able to defend. People were saying 4.5, others are saying 4. Who can defend the answer? Okay. Yes, Favor.
For me, I'm defending 4 because as you see, it is a square out there and it is 8 meters. So meaning that is half of it. So half of 8 is 4.
Okay, good. Thank you. Patricia. Oh, okay. Aini.
I'm defending 4.5 as it is the radius.
The radius. Aini, are you saying our circle? Does this height touch the end part of the circle?
No.
No. Is it still the radius?
No.
Okay. Okay. Yes. Okay. Yeah. So it doesn't touch. It doesn't reach. It only stops on the square. So since they have told us that this one is a square and they told us it is of 8, and you know that this is the center, so meaning here you have 4 and here you have 4. So that distance is 4 meters. And the moment you have it, then it means we are very good. So what are we going to form? We have something like this, whereby here you have your 4.5, here you have your 4. So our task is to find out the angle. So I'm interested in finding out this angle. Can everyone first try out? Okay. People are getting. The people who have not yet said anything. Audrey, do you want to take us through how to get the angle? Daniela, do you want to take us through? Okay, shall use car. Okay, okay. Hadia,
Yes, teacher.
can you take us through?
I unfortunately will not be able to take you through properly. I don't know how to explain.
Okay. Okay, yes, Jonah. Hadia, have you just joined or you have been on?
I joined like a few minutes before.
Okay,
Yeah.
okay,
We
okay,
can go.
okay, John.
When we are to analyze our question, we are given the hypotenuse and the adjacent. So
Okay,
we can use cos theta.
okay,
So cos theta is equal to adjacent over hypotenuse. And our adjacent is 4. Our hypotenuse is 4.5. Dividing it out, cos theta is equal to 0.8889. Yeah, theta is equal to cos inverse that.
okay. So, which will give us 27.26, and we can write it as 27.3 degrees. Now, after obtaining that, remember we have only got for one part. It means also it is the same angle here, which is 27.3. So we shall multiply it by 2, meaning that our angle will be 27.3. So 27.3, when you multiply by 2, you end up with 54.6 degrees. So now it means that the total angle we have is 54.6. Now, what is our next task? Oh. Now, our next task is to go on and find out. So you will agree with me that now we have this, the whole of this. So we have obtained our angle here as 54.6. We know our radius as the 4.5. We know it as 4.5. So we are going to obtain what is the area of this, of the sector. This is the sector we want. So now we shall say that our area of the sector is equal to theta out of the 360, then times the pi r squared. So which will give you 54.6 out of 360 times 22 out of 7 times our r, which is 4.5 squared. So when you do what? You place your calculator, 54.6 times 22 times 4.5 squared, divide by 360 times 7, you'll end up with something like 9.6525, and these are meters squared. Members, are we on the same track? Are we on the same page? 9.65. Anyone we are leaving behind? Okay. Okay. It seems we are together. Now, after finding that, remember, we must eliminate the segment, the minor segment. So now, let me divide like that. So, meaning we must remove this segment here, this one here, because we don't need it. We don't need it. So we need to know how big is this part here? How big is the segment? So in order for us to find it, remember, we have a triangle here. Hope we can see the triangle. You have this triangle. Oh, we have that triangle there. So we have to remove this triangle here in order for us to be able. But we said that in order for us to obtain the area of that triangle, I'm going to say that area of the triangle is going to be equaling to a half radius squared, then times the sine of the angle. So here we shall have a half times the radius, which is 4.5 times 4.5, then sine of 54.6. So we are going to place our calculators. Sine 54.6 times 4.5 times 4.5 divided by 2. So it will give us 8.25, and these are going to be our meters squared. Members, are we still on the same page? Okay, still the same page? Yeah. Now, can everyone tell us what is the area of this segment here? You can tell us what is the area of the segment of the minor segment, this one here. How big is this area here? Here. Which answer are you getting for that area? Oh. Okay. Yes, Desire.
So there we shall say area of the sector minus area of the triangle.
Okay. So to get the area is equal to segment area. So, okay.
Minus area of the triangle.
Area of the sector
Minus
minus
area.
area of triangle. Okay.
When you press the okay.
Mm.
When you press the calyx, you get 1.4025.
1.4025. 1.4025 meters squared. Very good. Okay. Now, after doing so, remember your circle has how many of those parts? So when you go, you notice that our circle has 4 of them. So this is 1, 2, 3, and 4. So you must remove all those 4. So meaning that when I come here, I must remove those 4. So I'm going to say that the total area to be eliminated. And this is what we call the segment area. Or the minor segment area. So to obtain it, we shall say 4 times 1.4025. And here, when you place your cal, or when you multiply times 4, you'll get your answer as 5.61. Now, after getting those areas that you're going to subtract, now find out what is the total area where the goat can reach. So meaning that we are going to obtain the area for the grazing. So it's going to be the total area of the circle. We had the total area of the circle, which was 63.64. So which was 63.64 minus this area, which is 5.61. And here we shall end up with 63.64 minus 5.61, which will give us 58.03 meters squared. Have we understood? Okay. 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 I think let me answer a question. Yes, Colin.
Sir, I beg your pardon, from where the total area to be eliminated?
The total area to be eliminated. Did you get it the way we got how we got the area for one small part?
Pardon?
The area for one small part.
Yeah.
Yes. But do you hope like when I go back to our diagram, you notice that here, this one here, one of it, like our answer, I think we have 1.40 something. Still, when you look at this one also has 1.4 something. Also, this one has the 1.4 something. Even this one has 1.4. So that means we must remove all these four. So you can say you get this plus this one plus this one plus this one. You add all those small areas together.
Yeah.
So that's what we are doing.
Okay, that's fine.
Yes, for you, what you can do is that for you can place the figure there and then you add all the four areas, one plus this one plus this one plus this one.
Okay, I now got it.
Okay, 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 okay. Hope that is very fine. I'm going to ask you to now just take a screenshot. Yeah, we may not be able to complete all the numbers. Take a screenshot of this. Hope you have finished. Take a screenshot of that. Okay. Yeah, hope you are finished. I can add you another one. I can add you. I can add you. Yeah. Okay. So you'll try out those numbers. You'll try out those numbers. I'm going to, don't worry, those who have not copied, I'm going to share it with you such that you can do it. Such that you can be able to copy them in case you have not done so. So I think we are going to end here for today. Tomorrow, we are not meeting. Tomorrow, I think it is Saturday. So tomorrow we shall not meet in the morning. But over the weekend, I'm going to send you some online what? Online quiz about circle properties. I don't know when you want it, either Saturday or what, but I'm going to send you an online quiz for you to try out. So on Saturday, I will send it early in the morning, but you try it. It will be open the whole day, even on Sunday. I think I can leave it open on Sunday, and then you try out. The next week, we shall start on something new, but you can suggest. Let me allow you to open your microphone and you suggest whether there is any topic